Okay, students. So this is on another lecture on this Lagrangian dynamics. So in this lecture, we are going to discuss one more problem: how to construct a Lagrangian, or how we can calculate the equation of motion for a particle under different conditions. So आज का जो हमारा topic है, so I am going to discuss one more problem on this Lagrangian dynamics, and the problem says that जो हमारी problem है, it says that अगर हमारे पास एक particle होगा, if we have some particle जिसका मास m होगा and it is constrained to move in a vertical plane, तो ये vertical plane में move कर रहा है, that means it's in that the particle जो हमारा है ये it is moving in the two-dimensional plane. Okay, and the trajectory that this particle having mass m will follow, so that is given by this equation. So that is given by this x and y coordinate by that's x equal to a cos theta and y equal to a sin theta. So that means हमारा जो पार्टिकल है ये टू डायमेंशनल ये प्लेन में मूव कर रहा है जिसका मास m है और इसके हॉरिजॉन्टल एंड वर्टिकल कंपोनेंट्स हमें दिए हैं, दैट इज x equal to a cos theta and y equal to a sin theta, and a is some constant, it has some numerical value, and we need to construct a Lagrangian in this case. तो हमें देखना है कि फॉर्म ऑफ Lagrangian क्या होगा in this case. So that means जो पार्टिकल की मोशन है it is confined or it is constrained to move in a plane. So that plane is our xy plane, right? So that means so we can solve this problem as, so that means हमारे पास एक vertical plane है. So suppose this is our xy plane and this will be our a cos theta और ये हमारा a sin theta. So that means we have some particle, हमारे पास एक particle है जिसका मास m है, right? And it is moving in this vertical plane. ठीक है? तो हमें देखना है कि Lagrangian की फॉर्म क्या होगी in this case. तो पहले हमें पता है कि अगर हम Lagrangian, when we write the Lagrangian, जब हम Lagrangian लिखते हैं किसी पार्टिकल के लिए और सिस्टम ऑफ पार्टिकल्स के लिए, तो हमें पता है कि हम Lagrangian लिखते हैं कि that is our kinetic minus potential part, right? So that means we know that Lagrangian that's equal to T minus V. So T हमारा kinetic part है, that's kinetic energy, और V हमारा potential energy, right? So that means I can rewrite this as, so this will be equal to 1 by 2, or you can write now. So let us first write what's our T here. So that is equal to 1 by 2 and V square. So that means हमारे पास, so we have some particle जिसका mass m है and it is moving with some velocity v, right? But this v has two components, so that means this velocity has horizontal as well as the vertical component. So that means because we can have, so it makes some angle theta here with this x-axis, and so this will be equal to some a cos theta and this will be a sin theta, right? Now इसको मैं लिख सकता हूँ, I can rewrite this as, so this will be 1 by 2 vx square plus vy square, right? So this is our kinetic. तो पहले हम kinetic energy calculate करेंगे, then I will calculate what will be the potential energy. उसके बाद हम potential energy देखेंगे, right? So in this case जो हमारी velocity है, तो velocity हम कैसे लिख सकते हैं? Because velocity is simply that is the rate of change of this displacement with respect to time. So that means vx को मैं लिख सकता हूँ और vx x square को मैं लिख सकता हूँ as dx by dt, इसको मैं लिख सकता हूँ dy by dt, because velocity has two components, horizontal as well as vertical component, because particle is moving in a plane, in a vertical plane. So that means I can rewrite this as, तो हमारी kinetic energy यहाँ पे होगी, so this will be equal to 1 by 2 x dot square plus y dot square, because जो हमारा vx है, so that's equal to dx by dt, और जो vy है, so that is equal to dy by dt, और इसको मैं लिख सकता हूँ, so this is our x dot and this is our y dot. Okay, तो simply मैंने इसको convert किया, because हमारे पास x and y components है, I can calculate its derivative and calculate the horizontal and vertical component of velocity, right? So that means if I calculate now, what's my x dot square? So because we know that x is equal to it's a cos theta, so x dot will be equal to, so this will be a into minus sin theta, and then because theta is varying here, so let's have a look. तो जो पार्टिकल है अगर ये यहाँ पे होगा तो इट हैज कंपोनेंट a cos theta. If this is varying, if particle is here, अगर ये पार्टिकल यहाँ पे शिफ्ट हो जाएगा m प्राइम, so that means in that case, so we have new theta dash. So that means theta is varying here. So that means this is our variable. It's varying, right? With respect to motion. Okay. So जो ही ये move हो जाएगा, so that means theta will be different. So that means x will be different. So that is why I need to differentiate that theta with respect to time. So that is d theta by dt, and that will be theta dot. So this is equal to minus a theta dot sin theta. Okay. And similarly, I can write that my y dot will be equal to, so that will be equal to, because okay, so let me write first what's my y here. Y equal to a sin theta, and y dot will be equal to a cos theta dot, because sin theta ki so differentiate, so it's cos theta, and theta ki theta dot. Okay? So this is theta dot. So this is theta dot, and this is theta dot. Okay. This will be equal to, okay, so we have calculated this. Now let's calculate what's my kinetic energy from here. So जो kinetic energy होगी, so this will be equal to 1 by 2 m x dot square. So that is minus a theta dot sin theta square plus a theta dot cos theta whole square. Okay. This will be equal to 1 by 2 m into a square theta dot square sin square theta plus a square theta dot square cos square theta. Okay. और इसको मैं लिख सकता हूँ, because you can take that a square theta dot out, so it is sin square theta plus cos square, so that is equal to 1. So that means इसको मैं लिख सकता हूँ as 1 by 2 m a square theta dot square. So this is our kinetic energy. Now, because our Lagrangian is, that is kinetic minus potential, right? Kinetic energy minus potential energy. So what will be the form of potential energy here? What's the form of V here? Because if we go for a conservative system, so if we go for uniform gravitational field, in that case, our potential energy will be simply mj and the that this, you take the derivative, or you can write that, because f is minus partial v by partial r, so you can write the potential energy will be equal to minus, that's equal to mgy. Okay, so that means, but why we know that? Okay, so I can rewrite then the what should be the form of v. So we know that also for uniform gravitational field, we can write that the form of v is, so that's equal to mgy, so that's equal to mg into a side, because so that means the particle is under that gravitational field, so we need to take the vertical component of that velocity, no, sorry, for coordinate. So that, so vertical component is, that is equal to a sine theta, y equal to a sine theta. So that means potential energy will be this one, right? Now we can easily, अब हमें पता है कि हमारे पास potential energy भी है, kinetic energy भी है, we can write the, or we can construct the Lagrangian from these two terms, right? So that means I can write then this Lagrangian is, that is T minus V, right? So we know that हमें already calculate है, that is T equal to 1 by 2 this. So this will be equal to 1 by 2 m a square theta dot square minus mg So this is the Lagrangian. Or if you are interested, you can also calculate the Lagrangian equation of motion, right? So because so you need to differentiate it with respect to theta. So that means agar मैं, if I, because the question says that we need to construct the Lagrangian for this case, right? But I'm saying that in addition to that, if you calculate the equation of motion, Lagrangian equation, right? So Lagrangian equation will be, so that will be d by dt of, that's partial L by partial t theta dot minus partial L by partial theta. So that will be equal to 0, right? So you can see that. So this basically gives you the nature of the motion of a particle, right? So what our question was up to this point. तो हमें simply देखना था कि Lagrangian क्या होगा यहाँ पे, right? So this is we have, this is now no interest for us because we need to construct only the Lagrangian for this case, right? तो ये हमारी first problem है जो हमने एग्जांपल उठाई थी Lagrangian dynamics, right? तो सेकंड प्रॉब्लम है यहाँ पे, अगर हमारे पास अब Lagrangian दिया होगा जिसका it has some form like L equal to Q dot square minus Q dot. So I'm taking Q as coordinate, huh? Right? Okay, this is so in general I'm saying that this coordinate is Q, right? तो Lagrangian हमारे पास दिया है किसी पार्टिकल का जिसका मास m है, right? तो हमें अब कहना है कि the nature of motion of a particle will be, तो हमें कहना है कि nature of motion क्या होगा. तो nature of motion means हमें बताना है कि whether the particle is executing some simple harmonic motion or that velocity it is some periodic motion or it's a free particle. तो दैट मीन्स हमें इसका नेचर ऑफ मोशन देखना है, राइट? तो हम कैसे कर सकते हैं? तो अगेन विद द हेल्प ऑफ दैट दिस इक्वेशन ऑफ मोशन, Lagrangian इक्वेशन, आई कैन सी द नेचर ऑफ द मोशन ऑफ ए पार्टिकल, राइट? बिकॉज हमारे पास Lagrangian है, तो जब Lagrangian है तो वी कैन कैलकुलेट दैट इक्वेशन ऑफ मोशन, Lagrangian इक्वेशन फ्रॉम दिस, राइट? So let's calculate that. So okay, so we know that. तो मैं लिख सकता हूं यहाँ पे कि जो हमारा Lagrangian है, तो दैट इज इक्वल टू Q डॉट स्क्वायर माइनस Q डॉट. Okay, so if I calculate now what is, so from Lagrangian equation, so from Lagrangian equation of motion, so Lagrangian equation of motion says that that is equal to d by dt of partial L upon partial Q dot minus partial L upon partial Q, that is equal to 0. Right? So let us calculate first what is our partial L upon partial Q dot. तो पहले हम देखेंगे what is our partial L by partial Q dot and then we will calculate partial L by partial Q. Okay, so what's our partial L by partial Q dot? So that is equal to partial by partial Q dot. So inside is Q dot square minus Q dot. So that is equal to, because I need to differentiate this term partially with respect to Q dot, right? So that means this will be equal to twice Q dot. Okay, and the second term यहाँ पे होगी, because this is partially, so you can take that with respect to that Q dot, तो यहाँ पे Q आएगा, so that is minus Q. So this was the value of, तो ये हमने क्या कैलकुलेट किया? हमने कैलकुलेट किया that partial L upon partial Q dot. Now we will calculate what's our partial L by partial Q. So that means we need to calculate that what's our partial L upon partial Q. So that is equal to Q of Q dot square Q dot. So that is equal to, because I need to differentiate this term partially, right? So that means, so first term 0 आएगी, right? So this is some v square and I will get here, so that will be equal to minus Q dot, because यहाँ पे मुझे differentiate करना है partially with respect to Q, so that is equal to minus Q dot. right? Now let us use now these values in our Lagrangian equation of motion. So from Lagrangian equation of motion, we have that d by dt of that partial L upon partial Q dot that is equal to 0. Or this is equal to d by dt of what's our partial L upon partial Q dot? जो partial L upon partial Q dot आया है, so that is twice Q dot minus Q. So that is equal to minus, because this is the value of that partial L upon partial Q dot. अब हमें देखते हैं what is our partial L upon partial Q. So that is equal to minus Q dot. So that's equal to 0. This is equal to, so this will be plus, and I need to differentiate this with respect to t. Like आप निकालते हो, because if Q is equal to x, so this is dx by dt, that's Q dot. And similarly, this is velocity, right? So you differentiate it with respect to time, that gives us acceleration. So that means it will be Q double dot. तो इसको मैं देख सकता हूँ as 2s Q double dot minus Q dot plus Q dot, that's equal to 0. Or you can write that twice Q double dot equal to 0 implies that A equal to 0. So because what's our Q double dot? So that is acceleration. So acceleration 0 के बराबर आता है. So when acceleration comes out to be 0, तो इसको मैं लिख सकता हूँ ना ऐसे d of Q dot upon dt. So that is equal to 0. जब dq partial dq dot by dt equal to 0, so we can say that Q dot is constant. तो Q dot constant होता है. So that means जब acceleration 0 होगी, so that means the particle is moving with constant velocity. It is moving with uniform velocity. Right? So जब uniform velocity से होगा, so that means it is a free particle. So it is also from Newton's first law. So Newton's first law tells us that a particle is in a state of rest or it is in a state of uniform motion unless some external force will act on that particle, right? So that means here the nature of motion of a particle is a free particle, right? Because acceleration 0 के बराबर आएगा, तो that means it has uniform velocity. It's moving with uniform velocity, so it is only possible for a free particle. So that means I can say that the nature of motion of a particle is free. Or you can write that the nature of motion is a free, it's a free particle. You can write it's a free particle, or nature of a motion is a free, right? So that means it's a free particle unless some external force will act on it. Okay. So these are the two problems on this Lagrangian mechanics, and in our next lecture I am going to discuss some more problems on these Lagrangian mechanics. Thank you very much.